You ever look at one of today's crazy complex skyscrapers and just wonder how on earth they built that with such perfect precision? Well, the secret isn't just in the steel and glass, it's in the data. Today, we're diving into Autodesk Revit, the software that's completely changing how we design, build, and even think about our buildings. So imagine this for a second. What if we could build an entire building down to the very last pipe, the last wire, everything in a perfect virtual world before anyone even breaks ground? This simple question gets right to the heart of a massive problem with old school construction. A tiny mistake on paper, that blows up into a huge, super expensive problem on the actual work site. And this slide just nails the difference. On one side, you've got the old way, static 2D blueprints. A drawing of a wall is, well, it's just a bunch of lines. If you change that wall, you have to go hunt down every other drawing and update it by hand, just praying you didn't miss one. But on the other side is BIM, a dynamic, single source of truth where everything is connected. Now, this new integrated way of doing things is called Building Information Modeling, or you'll just hear it called BIM. And it's so much more than a fancy 3D model. It's a complete revolution in how projects are managed from the first sketch all the way to demolition day. Okay, this is a really important point to get. BIM isn't the software itself. It's the process. It's all about creating this shared digital resource. The architect, the structural engineer, the construction manager, literally everyone involved, they're all working from the exact same information, all at the same time. So BIM really stands on three big ideas. First, it's that central hub of knowledge we just talked about. Second, it seamlessly brings all the different teams and their work together. And third, and this is huge, it isn't just for the design part. It's used through the entire construction and even for managing the building once it's up and running. Honestly, this is the absolute best way to picture it. You're creating a digital twin. This twin can be tested, analyzed, and perfected right there on the computer, letting you spot clashes and fix errors long before they become crazy expensive real-world headaches. So, if BIM is this revolutionary process, what's the tool that actually makes it all happen? Well, for a huge chunk of the industry, the answer is Autodesk Revit. Let's pull back the curtain and see how this software becomes the digital worksite. And get this, here's a great little piece of trivia that explains its whole reason for being. The name Revit literally comes from smashing together the words revise and end. The whole idea is to revise the digital model to end conflicts before they ever have a chance to show up on site. Now, you don't need to be a software expert to get the general idea here. Think of the ribbon at the top as your complete toolbox. It's got all your walls, doors, windows, you name it. The properties panel on the side is like an object's DNA. It tells you everything about whatever you've selected. And the project browser? That's your map to the whole building, letting you jump between floor plans, 3D views, and everything else. But this is where Revit truly separates itself from any old 3D modeling program. See, in Revit, you're not just drawing lines and shapes. You're building with intelligent objects that are packed with data. This quote from an expert just says it all. In Revit, a wall isn't just a dumb shape. No way. It's a smart object. The software knows what it's made of, how much it costs, its thermal properties, how much weight it can bear, pretty much any piece of data you can think of. And here's a perfect example of what we're talking about. Just look at all the information contained inside one single wall element. All this data can be used to automatically generate material lists, run energy analyses, and create incredibly accurate cost estimates. It's all in there. Okay, now this is where the real magic happens. It's all connected. It's called parametric modeling. So if an architect moves a wall just a few inches in the 2D floor plan, bam, the 3D model instantly updates. The elevation drawings update. Even the schedule that calculates how much paint you need for that wall also updates. One change, one time, and it fixes it everywhere, instantly. And because it's one central model, everybody can jump in and work on it together. The architects lay out the space, the structural engineers design the steel frame, and the mechanical and electrical engineers run all their pipes and ducts, all inside the exact same digital environment. This ability to have all these different teams working together in a single intelligent model, it just unlocks a whole new level of collaboration that was basically impossible with stacks of 2D blueprints. And that collaboration pays off in big, big ways in the real world. Everyone on the team sees updates in real time. But even better, the software can automatically run what's called clash detection. It can literally tell you, hey, your plumbing pipe is running right through a structural beam. Finding that on the computer saves thousands, maybe millions of dollars compared to finding it on site after the concrete's been poured. So when you boil it all down, the results are crystal clear. You get fewer errors, much faster project timelines, and a massive boost in efficiency across the board. By building it right in the digital world first, you can build it better, faster, and cheaper in the real world. And believe it or not, this is just the beginning. Today, these Revit models are being plugged into AI for generative design, into VR so clients can do immersive walkthroughs of their building before it even exists, and even AR to overlay the digital plans right onto the physical construction site. That digital twin is becoming more and more alive every day. So this leaves us with one last big idea to chew on. When a building is no longer just a physical structure, but a living, breathing database of information, from its first design sketch to its daily operation, how does that fundamentally change what it means to be an architect or an engineer? The future, it seems, is being built first in the data.